So welcome back. Today the second class on electrostatic. Now today we are going to discuss on electrostatic force. Now in the last class we discussed electrostatic, some fundamentals of electrostatics. Now electrostatics finds a lot of applications in different areas like in solid state electronics, which is used for the behind the concept behind the resistors, capacitors, transistors, and inductors, and also it finds some applications in high electric field devices and power transmission, lightning protection, X-ray machines, and also it finds some applications in computer peripherals like touchpad, keyboard, the working behind LCD display, and even in printers and cathode ray tubes. Now, any applications in industrial area? Yes, definitely it is having applications in paint spraying, electrochemical processing, and fine particle separations, and also in medical area it finds a lot of applications. ECG, the principle behind ECG, EEG, then scanning machines, and in agriculture also. So this is a summary of different applications that we normally use with electrostatics. Finds a lot of applications in different areas. Now let us look on some role of some rules for attraction and repulsion. We know the rules in attraction and repulsion of an electric charge. Opposite charges will attract each other, and but the similar charges will repel, and we will check a point here. Let us see here. In this case, here we have A, B, and D are charged plastic plates. They are all charged plates, and C is electrically neutral plates. Now let us look on A, B. Now we need to find here it already see here A, B, and C and A attract towards each other, and D and A is repel from one another. Now what will be the condition with the C and D? How will it will interact, and how the B and D will interact? ഇതാണ് നിങ്ങൾ ചെയ്യേണ്ട ഒരു പ്രോബ്ലം. ഇത് നിങ്ങൾ അനലൈസ് ചെയ്യുക. Say for example, I have given a positive charge for A. Then what will be the intuition from this condition? A positive charge കൊടുത്തു. Then what happens to the B? B attract ചെയ്യണമെങ്കിൽ എയിലേക്ക് attract ചെയ്യണമെങ്കിൽ B must be, yes, B must be negative. So replace B will be negative. Now in this case B is negative. Now let us see here. But what about B here? Here B is negative. Then definitely B is negative. Then what about D? We need to find. What about B? Again here A is positive, and these two D and A will repel each other. Then what will be the charge in D? എന്തായിരിക്കും ഡിയിലെ ചാർജ് എന്തായിരിക്കും? D is positive, so we can see D is positive. When D is positive, when D is positive here, D is positive here. Now D and C is here. See here, the C and A is attracting each other. Then what will be the charge? No, C is electrically neutral. It contains both positive and negative. Okay. Now this B and D will attract each other. So we can see C has both positive and negative. They are electrically neutral. So what happens is C and D will attract. Okay. And B and D also will attract. Here we can see B and D will attract here. B and D will attract because B is having negative and D is having positive, so it will attract each other. And here C and D, C is electrically neutral, so what happens is these two again will attract each other. So this will give you an overall idea about how the charges attract and repel each other എന്നുള്ളതിന്. Now the question is why these things will repel or attract. Why it repel or attract? എന്തുകൊണ്ടായിരിക്കാം ഈ രണ്ട് ചാർജ്ഡ് പാർട്ടിക്കിൾസ് അട്രാക്ട് ചെയ്യുന്നു അല്ലെങ്കിൽ അത് repel ചെയ്യുന്നു? Then there exists, this shows that there is an evidence of existence of a force between these charged bodies, and that force is what we call it as the electrostatic force, right? So we need to find that force. So what is the force between pairs of these point charges? A point charge is nothing but is a charge that occupies a region of space which is very negligibly very small compared to the distance between these point charges. Say it's very small charge. Now say for example, suppose I place a plus q1 means it's a positively charged, then there is a negatively charged q2, and definitely we know these two will attract each other because these are two opposite charges, so it will attract each other. Now that the attraction, the force of attraction between these two can be represented. These q will exert a force on towards a q2, and again there will be a force that is f21 where this q2 will exert on q1. ഇങ്ങനെയും ഫോഴ്സുകൾ നമുക്ക് റെപ്രസെന്റ് ചെയ്യാം. Again similarly we can have, if both charges are having positive charges, then these two will repel each other, and that force of repulsion is f12 and f21, right? Both are in opposite direction, right? Not in the same direction. These two forces are opposite direction. We'll see later. Now what happens if both the charges are negative? Again there will be a force of repulsion between these 2 point charges. Now we will look on to how much will be that force, and there are some fundamental laws associated with these electrostatics, and those laws are, one is Coulomb's law and other one is Gauss's law. Coulomb says law is applicable to in almost all point charge cases, but Gauss's law is something which is applicable for finding the electric field in a symmetrical case. Now let us look on to the Coulomb's law. What Coulomb says is that force between these 2 point charges, say I have a point charge q1 is here, and there is another charge q2, then we need to find what will be the force that this q1 will exert on q2. We will represent that force as f12. And suppose the distance between these 2 point charges is r12, we represent it as a r12. Why the name is because this is from q1 from the distance 1 to 2, that is r12. Now the force is represented as f12, that means force by q1 on q2. Okay, now let us see what Coulomb says is that force between these 2 point charges q1 and q2 is, that force is always along the line joining these 2 charges. So here q1 and q2, so that force must be along the line joining these 2 charges, so it is in this line. So that is why the direction of the force is in this case. Now what will be the magnitude of that force? And that is equal to, that is directly proportional to, the product of Q1 and Q2. The force is proportional to that existing force between these two charges is equal to, directly proportional to the product of charges Q1 and Q2. And it is inversely proportional to the square of the distance between these 2 point charges. Okay, so that is what Coulomb says, and we can write that F as, if you remove the proportionality, so we can write it as K into Q1 Q2 divided by R square. And Coulomb's law is also known as inverse square law. And so we need to find what will be this proportionality constant. We'll call it as K, where K can be expressed as K is equal to 1 by 4 pi epsilon. For in free space, it is equal to 1 by 4 pi epsilon naught. If the charges are placed in free space, then we can write it as 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. So this will be the force between these two charges Q1 and Q2. Q1 നും Q2 നും ഇടയിലുള്ള ഫോഴ്സ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ that's equal to the product of these charges divided by 4 pi epsilon naught into the R square. Okay, now we can calculate the value of epsilon naught, or the permittivity, or the dielectric constant of the medium, into the permittivity of the free space. We can write it as epsilon, and here we can write K as 1 by 4 pi epsilon naught, and its value is equal to 9 into 10 raised to 9 meter per farad. Now, what will be the force on Q1 due to the Q2? അങ്ങനെയാണെന്ന് വിചാരിക്കാം. ഇപ്പം നമ്മൾ Q1 കൊണ്ട് Q2ന്റെ മുകളിൽ ഉണ്ടാകുന്ന ഫോഴ്സ് ആണ് നമ്മൾ പറഞ്ഞത്. Q1 ഇവിടെ പ്ലേസ് ചെയ്യുന്നു, Q2ന്റെ മുകളിൽ Q1 ഇവിടെ എടുത്തു വെക്കുന്ന സമയത്ത് ഉണ്ടാകുന്ന ഫോഴ്സ് എത്രയായിരിക്കും? Now Q2 കൊണ്ട് Q1 ൽ ഉണ്ടാകുന്ന ഫോഴ്സ് എങ്ങനെ എത്രയായിരിക്കാം? The same phase, so we can say both these forces are equal in magnitude. Both of these forces are equal in magnitude, but its direction, their direction is opposite. Either its direction is along this line, and here we are applying the force along this line, so the force direction of the force is along this line. Again, the magnitude of these two forces are same. Now that's why we use Coulomb's law. It is this law is put forward by Charles Augustin de Coulomb, and he used these things. He and again, not that this law says that this magnitude of both of these charges are same. Sorry, the force between these two, magnitude of these two forces are same. So we can write Coulomb's law as the magnitude for both of these cases, it is equal to K into Q1 Q2 divided by R1 square, and K is known as the electric constant of the proportionality constant, and we'll use this law for finding the force between two charges. Okay, so ഇതാണ് നമ്മുടെ ഇന്നത്തെ ഡിസ്കഷനിൽ വരുന്നത്. അതിൻ്റെ direction of this force is along the direction of this unit vector along this R12, the unit vector. So we can write the equation as F12 as is equal to Q1 Q2 divided by 4 pi epsilon naught into R1 square into the directionality constant also. Okay, that's all now. Thank you.